Hello friends. So today we will start with the next topic, that is relation and functions. Okay. So before starting with the questions, let us discuss some of the points which audio studied, okay, in the theory part. So just some of the part we will revise it because those points will be required to deal with the questions. Okay. So first, as you know, what is meant by a relation? So as you know the definition, relation is what? It is a subset of the Cartesian product. Okay. Next, in that we are having some of the types. Empty relation. Okay. So what is meant by empty relation? Okay. Suppose we are having one set. That set is A. Set is A, and suppose that set contains some of the elements. Okay. Then suppose that A set elements, if they are not related, to each element, okay, or you can say they are not related to that same set, then that relation is called as what? Empty relation. The next we are having universal relation. Universal means what now? Each element present in that set A is related to the all elements to that set A is called universal relation. Reflexive means what? Reflexive is what? We have the definition for reflexive. We write the ordered pair, that is A belongs to R. Okay, it means what? The given relation is reflexive. Okay, means these are the definitions. A belongs to R. So this we write for reflexive relation. Next, symmetric, that is AB belongs to R implies BA belongs to R. BA belongs to R. This is for symmetric relation. Next, we are having with transitive. What the transitive relation says, that is AB belongs to R and BC belongs to R, that should implies AC belongs to R. This is for transitive relation. And next one we are having equivalence relation. So what is meant by equivalence relation? If any relation satisfies these three conditions, that is reflexive, symmetric and transitive, then that relation is called as equivalence relation. Okay. After that, next part we are having is what? Functions. In the functions part, we are having the two major definitions, that is one-one function and onto function. What is one-one function? That is every element of, suppose we are having one function, just for example, I am having the function is x to y. Then this f is, when this f is called as one-one, every element of domain, that is x, okay, having unique images in codomain, that is in y. Okay, means simply every element of domain have unique images in the codomain, then that function is called as what? One-one function. That is called as what? One-one function. Then what about onto? For onto, suppose if I again define one of the mapping, that is f is from x to y, then every element of y, okay, are having the images in x under f. Okay, means every element of codomain are having the images, are the images of elements of domain, then it is called as what? Onto. Then next one is bisective function. So when the function is called as bisective, when the function is one-one and onto, then that function is called as bisective. And whenever the function is bisective, then we can say that function is invertible. That function is invertible, or can say inverse exists. Inverse exists. Okay. Next point, a function f is from x to y, which is not one-one, then that function is called as many-one function. Many-one function. Based on this many-one function, we have not done any example in our theory exam, but in the competitive exam you may get the question on this many-one function. Okay. After that, we are having what? Composition function. What is composition function definition? That is g composition f of x can be written as what? G of f of x. G of f of x. So this is the definition of what? Composition function. Okay. And next part we are having is what? Binary operation, right? So that is what? So this, what I have taken this star. Okay. So this star represents what? Binary operation. Okay. So in the examination you may get with the representation as a star, or they may use another notation as this. Even this is also called as a binary operation. Okay. But this notation we are not used in our theory exam, because in the theory exam we use only the star, but you may get this representation also to for what, binary operation. So how it is given? So binary operation of, or you can say by a star of AB is equals to what, A star B. Okay, in this binary operation we have seen some of the laws, right? That is closure law, commutative law, associative law, and existence of identity. Okay, so most probably you may get the questions like whether the given binary operation is commutative, associative, or if it exists the identity, then what is that identity element. Okay, those questions you may get on this binary operation. Okay, then some more points I have written here, okay, which will help you to deal with the questions. Okay, these points were not yet studied in our theory exam. What I have revised this so far, this is we are already done with theory exam. Okay, these are the some of the points which will help you to deal with the competitive exam questions. Okay, so the first point is what, G composition F is 1 1. Okay, if G composition of F is 1 1, then that implies F is 1 1, not G. That implies what, F is 1 1. At the same time, if G composition F is onto, then here it is reversed now. Here G is onto, not F. Okay. Next point, if F is from X to Y, G is from Y to Z, are invertible function. Okay, then G composition is also invertible. Then we have the result is what, G composition F whole inverse can be written as F inverse composition G inverse. Okay, G composition F whole inverse can be written as F inverse composition G inverse. Okay, next point, if n of A is M, means number of elements present in the set A is M, number of elements present in the set B is N, and F is a function from A to B. Okay, A to B, then we have some of the points here. First point, the number of functions from A to B is, how to calculate, that is n to the power m, n to the power m. Okay, means to find out the number of functions from A to B, we use this, that is n to the power m formula. The next, if n of B is less than n of A, means number of elements present in the set B, if it is less than number of elements present in the set A, then there is no 1 1 function, there is no 1 1 function. Okay, next condition, if n of B is greater than or equal to n of A, then the number of 1 1 function is. Okay, so whenever it satisfies the condition, then that function is called as what, 1 1 function, means it represents for 1 1 function. Or to find out number of 1 1 functions, we have to use the formula is, that is npm. So this is what, it is a permutation, this is what, permutation. Okay, so by using the permutation concepts we can find the answer of that. Next point is, if n of B is greater than n of A, then there is no onto function, there is no onto function. And last point, if n of B is less than or equal to n of A, then the number of onto functions are n to the power m minus n factorial, minus m factorial. See, in these 4 points, when it is n of B is greater than equals to n of A, then number of 1 1 functions we can form. Okay, and if n of B is less than or equal to n of A, the number of onto functions we can form. And see, both are having different formulas. Okay, don't get confused with greater than equals to and less than equals to. So these are the some of the points which will help to solve the questions. Okay, so please pause the video to note it down. Yes, hello friends. So as earlier we have seen some of the definitions or concepts in that relation and function. Now we will go with the questions now. First question, let T be the set of all triangles in the Euclidean plane. So you know what is meant by Euclidean plane. Okay, let a relation R on that set T be defined as A is related to B. Okay, if, okay, how the relation is given among that A and B, A is congruent to B, A is congruent to B for all this AB belongs to T. Okay, T is what? It is a set of all triangles. Okay, then R is, so A is congruent to B. A is congruent to B. Okay, then what is that R? We have to check it. Okay, see, suppose now for reflexive, what is the definition? AA belongs to R. AA belongs to R. Then as per the definition, it is what? When it is A is related to B, then definition is A is congruent to B. Now when I am having A belongs to R, then definition is what? A is congruent to its A. Means what? Always any triangle is congruent to itself, right? So therefore R is reflexive. R is reflexive. Okay. Next is what? Symmetric. Next is what? Symmetric. What the symmetric definition says? That is AB belongs to R should implies BA belongs to R. Okay. Now let's check. Let's check now. Here AB belongs to R. It means what? A is congruent to B. A is congruent to B. So obviously it implies what? B is congruent to A. Okay, suppose if I say A is similar to B, then obviously B also similar to A. In that case, so therefore here A is congruent to B always implies B is congruent to A. Therefore R is symmetric. R is symmetric. Let us check for transitive now. What is the transitive definition? AB belongs to R and BC belongs to R should implies AC belongs to R. Now see here, AB belongs to R means what? A is congruent to B and here B is congruent to C. Then obviously it implies what? A is congruent to C. See here, A is congruent to B and here B is congruent to C. So obviously A and C will be what? Congruent. Therefore R is transitive. So in this first example, R is reflexive, symmetric and transitive when it satisfies all the three conditions, and that relation is called as what? Equivalency relation, right? Then just check it. Do we have any option in that? Here reflexive but not transitive, transitive but not symmetric, transitive but not reflexive, and none. So option D will be correct in this because it is a equivalence relation, but that option is not there in this. So option D will be correct. Second question, consider the non-empty set consisting of children in a family and a relation are defined as, that is means the relation is given among this A and B is, that is if A is brother of B, A is brother of B means the relation defined among this A and B as what? A is brother of B, then R is. Options are symmetric but not transitive, transitive but not symmetric, neither symmetric nor transitive, D both symmetric and transitive. Okay, so let us check now. Second one, again reflexive, will check it first. That is what? A belongs to R. Okay, when it is AB, what is the relation? A is brother of B. Now I am having AA belongs to R. Then what I will get? A is brother of A. Is it true? No, A cannot be the brother of itself, right? So therefore it is not reflexive. R is not reflexive. Okay. Next you check symmetric one. Symmetric is what? AB belongs to R. It means what? A is brother of B. It is true. A is brother of B. But this implies whether B is brother of A. Whether B is brother of A? No, which is not true. Okay, because B may be the sister of A also. B may be what? Sister of A. Therefore that is not true. So hence this is not reflexive, not symmetric. Not reflexive, not symmetric. Let us check for transitive. So for transitive definition is what? As already we have written in the first question, AB belongs to R means what? A is brother of B and B is brother of C. Then it may be A is brother of C. This is possible. This is possible. So therefore what we can conclude? R is not reflexive, R is not symmetric, but R is transitive. So do we have that option? Symmetric but not transitive, transitive but not symmetric, and D is what? Both symmetric and transitive, but this option is not correct. So here neither symmetric nor transitive. Okay, so as per the options, do we have that option? Just check it now. It is not reflexive, not symmetric, but transitive. So I may write transitive but not symmetric. I think this option will be correct. Okay, next question. Let A is equals to 1, 2, 3. The total number of distinct relations which can be defined over A is. So here A is equals to what? 1, 2, 3. Then what we have to find? Total number of distinct relation defined over that set A is. Okay, so for this we have the formula to find out the total number of relations defined over the any set. Okay, that is formula is what? 2 to the power n. That n is what? Number of elements present in that set A. So how many elements are there? 3. So this is 2 to the power 3. Answer will be what? 8. So therefore option B will be correct. Okay, next question. The wide relation on the set A is, options are reflexive, symmetric and transitive, option C reflexive and symmetric, and option D reflexive and transitive. Reflexive and transitive. So one thing you keep in mind, wide relation is always symmetric and transitive but not reflexive. Why it is not reflexive? Because to define a reflexive, what we must have, that each element is related to itself, right? But in this case it is a wide relation, therefore there is no elements in this relation, therefore you can't relate any element to the itself, right? So therefore this relation is not reflexive but it is symmetric and transitive. So therefore I think option B will be correct in this. Okay, fifth question. Which one of the following is an equivalence relation? Okay, then options are, see they have given some different relation. R1 is a relation, R2 is given, R3 is given and R4 is given. In the R1 relation, what we have the definition is modulus of A is equals to modulus of B. Option B, A is greater than equals to B. Option C, A divides B. And option D, A is less than B. Okay, as you have solved some of the questions in the theory exam, for this greater than or less than, okay, for this greater than and less than, it is not equivalence. Okay, so just skip these two options now. Now left with now option A and option C. Okay, again here option C also, A divides B. Okay, so in this option also it is not becomes equivalence relation, because if I say for symmetric A divides B, but B cannot divide A, so here it is not possible to show symmetric, right? So therefore if one relation is not satisfied, means what? It is not equivalence. Therefore we are left with only last option now, that is modulus of A is equals to modulus of B. So in this case if I write for reflexive, obviously A is equals to A, reflexive. Then if I say A is equals to B, then obviously B is also equals to A, it is symmetric. Then for transitive, if it is A is equals to B and B is equals to C, then obviously it implies what? A is equals to C, it becomes transitive. Therefore option A will be correct, because all the three conditions are satisfied, and therefore it becomes what? Equivalence relations. Okay, I hope you understood these questions. So please pause the video to note it down. Hello friends, so this is the continuation of the relation and function topic. So in the last video we have seen with the introduction and some of the questions. So I'll continue with the next question here. Let R be the relation in N, that is set of natural numbers, given by R is equals to the ordered pair AB such that A is equals to B minus 2 and B is greater than 6. Choose the correct one of the following options. Okay, so they have given one relation here, A is equals to B minus 2 and condition is B is greater than 6. Okay, then among this which option will be correct, means which ordered pair will be belongs to that relation R. Okay, now for example, if I take first one, A is 2, B is 4, if I take it, then what will happen? If I substitute B is 4 here, then I think you will get the answer is 2, then 2 is equals to 2, it will satisfy. But what the condition is given here, B should be greater than 6. Okay, then B should be greater than 6 means which options we are having? B is this, so greater than 6 here and here, right? So you have to check it for only that option B and D. Okay, I think also you have to check it for option C also, because here 8 is there, right? So if I check it for first one, that is if A is 3, right? So is 3 is equals to B is 8. So if I put there, so it is 8 minus 2, you will get the answer is 6. But 3 is not equals to 6. Okay, that option is not correct. Then check it for option C. Okay, then that is 6 is equals to, okay, B is 8 again. So if I put 8 here, 8 minus 2 is 6. So 6 is equals to 6. I think the option C will be correct, because that option will be satisfied for the relation R. Okay, next question. The identity element for the binary operation, see basically we use the binary operation star. Okay, but this is another notation as I have given in the introduction class. Binary operation defined on A star B as, that is A star B is equals to AB by 2. Okay, so for this binary operation you have to find out the identity element if it exists. So here solution of the seventh one, as you know what is the definition of identity element, means to find out the identity element, what we use the definition is, it is A star E is equals to E star A is equals to A. So this is the definition to find out the identity element. Take any one part from this and just go on simplifying. So A star E is equals to A. Okay, but as per the definition, what is A star B here? AB by 2. Then what is A star E then? It is AE by 2, which is equals to A. In this A get cancelled. So what is left then? That is E is equals to, A get cancelled, that is A1's A, A1's A, right? So E by 2 is equals to 1. 2 you transfer, it will multiply. So this implies E is equals to 2. E is equals to 2. So therefore option C will be correct. Okay. Next question. Let R be the set of reals, means real numbers, and binary operation, this star be the binary operation defined by A star B is equals to A plus B minus AB. A plus B minus AB for all AB belongs to R. Then identity element under the binary operation is, means you have to find out the again identity element for this. So as we have taken the definition here, okay, so just I'll go with one part itself. A star E is equals to A. Same definition you have to use, but I have taken only the one part. Okay, then what is A star B? A plus B minus AB. Then what is A star E then? A plus E minus AE, which is equals to A, Then here E minus AE is equals to plus A transfer to this side, it becomes minus A, so it becomes 0. What is common among this? E will be common, left with 1 minus A is equals to 0. Then it is the product of two elements. Okay, when I transfer this 1 minus A to other side, it will divide. So 0 by anything is what? 0. Therefore E is equals to 0. E is equals to 0. Therefore option A will be correct. Next question, that is question number 9. Let f is from R to R be a function defined by f of x is equals to 1 by x for all x belongs to R. So here x is belongs to the set of real numbers, and you know how the real numbers are, that is from minus infinity to plus infinity. Okay, So here minus infinity to plus infinity, in between 0 is there, means minus infinity to 0 and 0 to infinity, right? So the options are what here? It is a 1 function, onto function, bisective function, and none of the above, right? So see here, it is a set of real numbers, right? So as I given the set is what? It is minus infinity to plus infinity, and in between 0 is there. Suppose if I choose this 0 now, if I choose this 0 as a x value, and if I put it here, then 1 by 0 will be what? Infinity, which is not defined. Okay, so therefore I think not a defined option is not there, so therefore none of the above, none of the above. Okay, because if I put 0 here, 1 by 0 will be what? Infinity, then not defined, then function will be what? Not defined, but not defined option is not there. So we have the option is what? D, that is none of the above. Okay, next question, that is question number 10. Let f is a mapping from R to R, be a function defined by f of x is equals to 4x plus 5, then f is injective, surjective, invertible, and none of the above. Again, injective means 1 1, surjective means onto, invertible means what? Inverse exist, and this option is D, that is none of the above. Let us check now. This given function is what? Whether it is 1 1, onto, or invertible, right? So here f of x is equals to 4x plus 5. F of x is equals to what? 4x plus 5. So let us check for 1 1 now. What the 1 1 function says? Suppose we have to choose the two elements belongs to domain. Domain is R here. Okay. Then f of x1 is equals to f of x2. F of x1 is equals to f of x2. Okay. But what is the definition here? F of x is 4x plus 5. Then what is f of x1? 4x1 plus 5, which is equals to, what is f of x2 then? 4x2 plus 5. Then plus 5 get cancelled using the right cancellation law. Okay, left with 4x1 is equals to 4x2. Now again using the left cancellation law, 4 get cancelled, left with x1 is equals to x2. Means what? F of x1 is equals to f of x2. It implies x1 is equals to x2. Therefore what? F is 1 1. F is 1 1. And as we know, every 1 1 function is onto. Every 1 1 function is onto. So I am not going to prove the part of onto here, because we know that every 1 1 function is onto. So therefore this function also becomes what? Onto. Okay, when the function is 1 1 and onto, 1 1 and onto, then that function is called as bisective. And if any function is bisective, then it implies what? Invertible. So option C will be correct. The function is invertible. Okay, why it is invertible? Because it is 1 1 and onto. If it is 1 1 and onto means what? Bisective. Bisective means what? Invertible. Okay. Next question. Set A has 3 elements, B has 4 elements, then number of injective mappings means what? Number of 1 1 mappings that can be defined from set A to B are. Okay, so in the first class might be have given in the introduction class some of the points. Okay, now from that points one result is useful here. See n of B. Okay, I will write here. Question number it is 11. So n of B is 4, n of A is 3. Okay, then we have the condition. See here, n of B is 4, n of A is 3. So therefore which condition? N of B is greater than equals to n of A. Here n of B is greater than what? N of A. So if n of B is greater than equals to n of A, then number of 1 1 functions are. Okay, what the result is? NPM. Number of 1 1 functions are what? NPM. Permutation. What is n here? So here NPM. Okay, so therefore n we have to take it as the n, that B bigger value. So it is 4p3. 4p3. The answer is 4p3. It is a first year concept, permutation. So this 4 we have to arrange in 3 places. So therefore 4 into 3 into 2. Arrange in 3 places. 4 into 3 into 2. So 4 3s are 12. 12 into 2, it is 24. Just check it whether we are having that answer in the options. Yeah, then option C will be correct. Okay. So in these examples, most I think some of the questions are taken with binary operation as well as with functions. Okay. So here you have to be very perfect with the definitions as well as some of the standard results. Okay. So please pause the video to note it down.
I'm an icon, man. And my girl about a 10. I should fuck her in a Benz.